right. So we are now live streaming again. Welcome back to those who are joining the party. Going over some notes here, we are learning about linear inequalities. We have really completed single variable linear inequalities, which was more of a review anyway. And now we're ready to move on to two variable linear inequalities, and those take the form of a graph. So that's what we're going to be talking about here tonight, and this is the lesson that will be delivered tomorrow. So what is going on now? All right. I've been having some issues with this computer today, so I may have to suddenly stop the live stream and restart the computer, but we will see. Okay. So, actually I want to get ahead of that a little bit and just close this program out and restart it. Hopefully that will alleviate tech issues. Okay, so now what we want to talk about is graphing linear inequalities. So we'll call this section 2, graphing linear inequalities. Okay, so right away we need to put it in slope-intercept form. Quick reminder, this is a big one, guys. Slope-intercept form, which we'll just abbreviate slope-int, is y equals mx plus b. And all we're going to do now is solve this equation in that form, but replace that equals sign with whatever inequality symbol we end up with. Remember, the inequality symbol that is there right now, which is the less than or equal to symbol, will change if we end up having to multiply or divide by a negative number. Heads up, it looks like you're going to have to do that, but actually you won't. But I'll show you how that all comes about. Let us find a good color, something contrasting with the black color. We use this kind of lighter blue. Now, I want this x term to go over to the right side of the inequality, and we're going to treat that inequality just like it's an equal sign, where I've got to do the opposite operation, or the inverse operation of addition, or of subtraction, which would be addition. So I'm going to add 3x to both sides because my goal is to move that 3x over to the right side of the inequality symbol. Well, these are additive inverses, so they cancel out. Let's use our magic cancel brush there. And the 2y remains. Let me get my black pen loaded here. The 2y remains, and it's going to travel down and sit right here. 2y. I did not add a multiply or divide by a negative, so this stays less than or equal to. And now I'm going to cleverly put that 3x up front and then pull down that plus 9. Okay, so 2y less than or equal to 3x plus 9. Final step. Divide everything by 2. Okay, this isn't going to work out very pretty, but you'll get the point. Okay, so again, we can cancel. Now I've got the y by itself, I did not divide by a negative, so it's still less than or equal to. And now we have something that looks very much like a slope-intercept form equation of a line. We have y is less than or equal to 3 over 2x plus 9 over 2, which is 4.5. Now I'm going to put it in decimal form because we are going to graph it, and that decimal form will be more helpful for us. I'll leave the slope m as a fraction because I want to interpret that as rise over run. So underneath this, I'll just write y mx plus b so you can see where these values map. So the m is 3 over 2 and the b is 4.5. So again, quick reminder here, ladies and gentlemen, this m is the slope, which we interpret as rise over run. And this b is the y-intercept. Okay, that's where x is 0. All right, so I think we're ready to graph. What we need to do is label our axis and mark off our axis points in some clever way. We'll try it like this. This is going to be 0.51. 1.52, 2.53, 3.54, 4.5. And we'll make some marks here. This is 0.5, then 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. Okay. I better do the same thing on the x-axis, and I'll go 0.51, 1.52, 2.53, 3.54. Same in the other direction. Negative 0.5, negative 1, negative 1.5, negative 2, negative 2.5, negative 3. So let's just label that negative 0.5 and then negative 1. And we get the idea. We don't have to label all the points. Just kind of get it going so you know what's happening. Gets a little bunched in there. So let's graph this thing. Let us pick this cool color here. And what we're going to do is start out by asking ourselves, what symbol are we using? Okay, so focus on the symbol. This symbol here, less than or equal to, okay, has a solid line. Okay, if it had just been less than, it would be a dashed line, but it's not less than, it's less than or equal to, so there's going to be a solid line. Very important to know when you're doing these linear inequalities. So let's go to the y-intercept, which is 4.5, and we'll put a closed-in circle. And now we're going to use rise over run. Now, the way I've drawn this graph, it's going to be much easier to go in the reverse direction. So instead of going rise 3, run 2, I'll go the other way. I'll go down 3, over 2 to the left. Now be careful that you go down a whole number and not just half a number. So we're going to go from 4.5 to 3.5. That's down 1. 3.5 to 2.5. That's down 2. 2.5 to 1.5. That's down 3. Okay, so now I'm going to go over to the left 2 places. Over 1 whole place and then over 2 whole places. I'm actually going to do that again, so make sure I get it right. Over 1 whole place, over 2 whole places. So about right there is another point on this inequality curve. Now I need the ruler to connect those dots. So we'll connect those dots, and what we're going to use here is a solid line. I'm going to get a solid line, draw it right through, just like that. So this looks almost exactly like graphing a regular old equation. Now here's where things get different. And now we have to add a note here. Remember, we shade below. Here's the little helper that I've been using, and it's been successful. So you got a filled in dot, right? Solid line. And we're shading below that line. Okay, so we're going to be shading. Ooh, I need to make that much bigger. We're going to be shading below that line. Okay, so I want you to think about the line like airplane wings. Below a tilted line kind of gets a little bit, so it gets a little bit weird to think about, but basically these airplane wings, it's like an airplane flying through the air, and then it's kind of banked to the left, but below the plane is still down here. So don't shade to the left of the line when you're graphing in a coordinate plane. Shade below the line. And now let's get to shading for real. Okay, we're going to shade here below the line. So the solution area for the system of this system of linear, or this not system, but for this linear inequality is right here. It's all of this, you know, it's kind of hard to shade it all in, but it's this whole area. Now, I'll just give you a heads up. A question that might get asked on the STAR test, and also on maybe a test that I give you, would be a question like this. Let me think about it for a second. 2, 1. All right. Here's a question that we might ask, and you might get this on the STAR test. Look over here in the bottom right of the screen. Does 2, 1 fall within the solution set of, and then we'll write this thing 2y minus 3x less than or equal to 9. Okay, so there's like this is like a STAR type question here. Does 2, 1 fall within the solution set of 2y minus 3x less than or equal to 9? All right, well, we already graphed it, we solved it, and we graphed it. It's good for us now to go and find 2, 1. Here it is. Right? That's 2, 1. Question is, does that fall within the shaded region? Yes, it does. So the answer to this little question over here, if you saw this on a test, this would be yes, absolutely. All right. And, you know, the way that they'll actually present it, so they'll just ask you yes, no. They'll probably give you multiple points, and they'll say something like, which of the following points fall within the solution set of this linear inequality? And you'll have to check. Now, one big point that I want to make sure I teach tomorrow is, what if they ask you about, let's say they ask you about this one right here, which would be -1, -2, 1.5. Let's say, what if instead of this, what if they ask you about -2, 1.5? All right, well, that point is right here. Okay, this is -2. So the thing is, this falls right on the line. Now, because it is less than or equal to this point, -2, 1.5, that absolutely falls within the solution set, because the green shaded region includes the line. Okay? So when it says less than or equal to, that means that if you plot a point right on the line, that is part of the solution set. If it had just been less than and that point had been plotted, this is always confusing, it is not part of the solution set, and it would be an open circle. Okay? So that is really, more or less, we'll just be doing variations on this theme. This is how you graph linear inequalities. And I've kind of put everything into this one screen here. So this is all the notes that you need to do that part of the Delta Math homework. So if you're watching this right now, you already have enough information to go start on the Delta Math homework for graphing linear inequalities. Not graphing systems yet, although let me just tell those folks who are interested in working ahead, all you do when you graph systems is you graph each of these inequalities. Like if you're given a system that would be like a minimum of 2 inequalities, you graph both of them, and then in that system, there will be some region, I don't know, let's say that the other one ends up being graphed and it kind of looks like this. All right, and let's say that you're shading below that line too. This bounded region in here, okay, this region in here is the solution set to a system consisting of 2 inequalities that graphed like that. All right, so you could get a question where they say which point falls within the solution set of the system of inequalities. Let me put it this way: systems of inequalities is so much easier than systems of equations because it's very image based. It's very graphical. It's very kind of like intuitive. Yeah, you understand if the area that overlaps, that's going to be the solution set for 2 separate inequalities. But that's looking ahead by a whole day. We will be getting to that on Friday. And that, after we do systems of inequalities, will totally conclude the unit on linear inequalities. So I'm actually eager to see how people handle this. It's fun. I think it's a lot of fun. And I think Delta Math is going to make it even easier, but we will see. So that's actually all I've got to plan for tomorrow. And quite frankly, I mean, getting into Friday, we're just kind of going to compound the issue, and we'll see how it goes. All right. So thanks so much for watching. If you did, make sure to like and subscribe. Hit that notification bell so you're always alerted to when I release new videos on this channel. Thanks.